Hello everyone. Today I would like to show you another spatial analysis based on linear regression models or linear regression analysis. First of all, I put two links in this Excel to show you the mathematical background of this analysis. First link showing us the introduction of this linear regression analysis based on independent variable and dependent variable, and the simple step-by-step mathematical background of this analysis. We have to know about this mathematical background just only theoretical form. In our course, we have to calculate this linear regression in Excel program. But if you know about theoretical background, it's much easier the interpretation of results. Second link also based on background mathematic analysis, showing us this video have to calculate the mathematical equation of linear regression model in one-way linear regression model x and epsilon. So today there is just working with GDP per capita and population data based on a lot of data. About the mathematical background, I can't talking about. Please see this two YouTube link. After that, you have to analyze these economic geographic differences. So let's calculating in Excel linear regression models. First of all, the question is that in country level, because the map is same like the before, linear regression, I want to know that what is the connection between GDP per capita values based on country levels. Independent variable, because this is a timeline comparison, independent variable, the data is based on this year, and dependent variable, this data. So first of all, we have to do this, and after that insert charts, scatter dot charts, click. After that we can see data 2010, 2010, and after that we have to click one dot, and after that you can see every dot is clicked. After that right click, add trend line. We can see a linear trend line of this. If you have another options, logarithmic, polynomial, exponential, there is a lot of options, but we have to analyze linear connection between GDP per capita data. After that, display equation on chart, click, and after that display R-square value on chart. You can see these values. First, you can see the equation value. If you see or saw the calculate linear regression video, you can know about a lot of this equation value. And after that, you can see R-square value. R-square value means that the earlier variables almost 90% determine the 2010 values. So the earlier GDP per capita differences more than 85% determine the later data. This is a very high level. If you detected above 50% or 50 value, because this is the same situation like Gini index. If you multiply with 100, you can see the percentage form of the calculation. So if you see above 0.5 values or above 50% values, this is moderate connection, causation between the independent and dependent variables. If you see above 65 or 70% or 0.7, you can detect a strong linear regression. Independent variables have a strong influence to the dependent variables. So let's move. We analyze a population 2004 compare with 2008. The situation is same. Insert charts scatter dot. You can see that. Left click, after that right click, add trend line. After that, trend line options linear, display equation on chart and display R-square on chart. You can see these R-square values. In country level, this is a very big determination. There is no significant difference between countries' population in this timeline comparison. So the R square very close to 1 point or 100%. In real life and real analysis, we can see a lot of moderate and strong correlation, for instance, between educational level, very big regression with income level or urbanization influence a lot of economic effects. So in urbanized area, we can see higher GDP or higher income. So the regression trend is a statistical methods to analyze the connection and determination factor of independent variables to dependent variables. Let's move on. Calculate in another level Let's move on and analyze based on NUTS3 level the regression analysis. First of all, analyze the GDP per capita values each NUTS3 regions. This is also a timeline comparison. In theoretical form, the independent variable, the 2004 GDP per capita values of each NUTS3 regions. The independent variable is 2010. Same situation, insert, charts, scatter dot, and after that you click left. There is no problem if you can see in this points you cannot see every point in this situation. There is no problem because a lot of dots, but the analysis based on every point. So there is no problem if you not see that each point selected in this case. Add trend line. You can see linear, display the equation chart and R-square. You can see a very strong determination factor or determination influence. This also showing us a very strong territorial differences in post-social countries. Post-social countries have not three regions. There is no surprise in this case. But analyze also the connection between population in each NUTS2 regions and GDP per capita. Because I think the hypothesis urbanized areas with lot of population generating more GDP than rural areas. And I would like to know about what is the determination factor of population. How much determining the population of each NUTS2 regions, the GDP per capita values. So, first of all, analyze GDP per capita values and population. 2004. The method same, we creating a scatter dot chart, and after that right click, add trend line and display equation on chart and R-square. You can see the mathematical determination factor of population to GDP per capita. You can see that R square 0.3 little bit higher this value, so the population differences determine the GDP per capita around 34%. This is not as high as before because this is not a timeline comparison. This is the comparison between two variables, population and GDP per capita. This showing us in one multiply regression analysis, we can see that only population concentration determining not as high the GDP differences as we know. So in other cases, we can analyzing another variables, for instance, educational level, infrastructure, situation, a number of institutes in not three regions. So in, for instance, another regional analysis, we can see that a lot of uh, variables is based on multiply independent variables determining, for instance, GDP. I put publication about Airbnb analysis in New York City. You can see a different program, SPSS IBM program. You can see that the multiply regression analysis based on a lot of determination factors. So this is a simple form of regression analysis, and you can see in articles in a multiply version of this analysis. But in this course, you have to know about this simple regression form. One variable, how much determined another variable. This is the clear situation. So if you have to compare these variables, first of all, let's see 2008, the year of the financial crisis, and after that, see the 2010 variables. What is the difference between population and GDP per capita variables? What is the determination factor? Let's know about this. Information 2008 2008. The calculation is not hard, interpretation is harder. Trendline linear R-square equation. You can see that 2008, the year of the financial crisis, we can see that the determination factor is higher than before. The population differences, the population variables determine the GDP per capita around 43% or 0.4. So little bit higher than before, but not enough because these values also below 50%. So these values not as high as in statistical methods, um, like the connection. But we can see a moderate connection. This based on this low value based on the NAT3 level, because we can see around 2000 polygons. I think 180 number of cases, lot of cases with very difference between the NAT3 regions. So let's see the last situation, calculating 2010. After the financial crisis, we can see regression between population and GDP per capita. Oh, sorry. Let's calculating again. Oh, a little bit mistake. So in this case, insert charts, scatter, left click, one dot. After that, right click, add trend line, linear R square equation. So after the financial crisis, the R square values is stable, higher than before 2004. After 2004, the value is higher than before, but in financial crisis year and after that, we can see that the more populated NUTS 3 regions generate more GDP and generate more GDP per capita values. This is a very big evidence of the financial crisis caused the rich regions or high populated regions generate higher GDP and rural areas generated uh, lower GDPs. This is a very big question in this year. Another economic crisis based on uh, not financial, based on real economic crisis, generating another patterns of this or not. This is a question of the future. Your homework based on the same situation. Let's do the regression analysis of GDP per capita timeline comparison based on these variables 2014 and 2017. Please analyze and put next to the datas these charts. Okay, you can see one. I would like to see one chart based on this timeline comparison. I would like to see another one based on population, and after that I would like to see one comparison based on GDP per population 2014 based on NUTS 3 regions of these post-social countries. And last, fourth charts based on 2017 data. Understand? I would like to see four linear regression charts based on linear analysis. So today this is the lecture. Have a nice week and have a lot of information about this linear regression. Bye.